with street lamps, interact with vegetables, resurrect dinosaurs, and see them up close. Find a way out before despair. In the era when everything is connected, technology brings such imaginations to life. Data communications networks with a super capacity create order out of torrents of data. Data communications networks with intelligent experience replace best effort with SLA guaranteed forwarding. Data communications networks with autonomous driving replace manual intervention on late-night shifts with network autonomy and self-healing. Today, data communications networks bursting with intelligence harness the power of the four engines. Connect people, connect enterprises, connect computing power. Laying a digital foundation for new infrastructure. Enabling a digital bridge for all industries. Working behind the scenes, intelligent cloud network ensures shopping is more personalized than ever. Every financial transaction is smoothly made. Valentine's gifts are swiftly delivered via robots. Each question has more and richer answers. Every life receives the respect it deserves. And a new journey can be embarked on fearlessly. Connectivity will never cease to evolve. Because no matter where we are, we must connect with our loved ones. And to the road we must take. Connecting value. Connecting hope. Connectivity is limitless. Connectivity knows no bounds.
四山洞拐四下升线，广州至常州。
There's a house we can build. Every room inside is filled with things from far away. The special things I compile, each one there to make you smile on a rainy day. They can say it all sounds crazy. They can say we've lost our minds. I don't care if they call us crazy. Run away to a world that we design. Every night I lie in bed, the brightest colors fill my head. A million dreams are keeping me awake. I think of what the world could be, a vision of the one I see. A million dreams is all it's gonna take. Oh, a million dreams for the world we're gonna make.
The history of human civilization is tightly interwoven with progressing connectivity. From not records to written languages, from signals in enclosed turrets to win-win free trade, from post riders to instant communication. We never stop pursuing and redefining connectivity. Taking each step firmly, we extended connectivity into new, untouched areas beyond the known world. What wonders can we see in connectivity today? Communicate with street lamps, interact with vegetables, resurrect dinosaurs and see them up close. Find a way out before despair. In the era when everything is connected, technology brings such imaginations to life. Data communications networks with a super capacity create order out of torrents of data. Data communications networks with intelligent experience replace best effort with SLA guaranteed forwarding. Data communications networks with autonomous driving replace manual intervention on late-night shifts with network autonomy and self-healing. Today, data communications networks bursting with intelligence harness the power of the four engines. Connect people, connect enterprises, connect computing power. Laying a digital foundation for new infrastructure, enabling a digital bridge for all industries. Working behind the scenes, intelligent cloud network ensures shopping is more personalized than ever. Every financial transaction is smoothly made. Valentine's gifts are swiftly delivered via robots. Each question has more and richer answers. Every life receives the respect it deserves, and a new journey can be embarked on fearlessly. Connectivity will never cease to evolve, because no matter where we are, we must connect with our loved ones. And to the road we must take. Connecting value. Connecting hope. Connectivity is limitless. Connectivity knows no bounds.
Chirisun avan dagat dere wache
四山洞拐至下宣线，广州至当地。
There's a house we can build. Every room inside is filled with things from far away. The special things I compile, each one there to make you smile on a rainy day. They can say it all sounds crazy. They can say we've lost our minds. I don't care if they call us crazy. Run away to a world that we design. Every night I lie in bed, the brightest colors fill my head. A million dreams are keeping me awake. I think of what the world could be, a vision of the one I see. A million dreams is all it's gonna take. Oh, a million dreams for the world we're gonna make.
The history of human civilization is tightly interwoven with progressing connectivity. From not records to written languages, from signals in enclosed turrets to win-win free trade, from post riders to instant communication. We never stop pursuing and redefining connectivity. Taking each step firmly, we extended connectivity into new, untouched areas beyond the known world. What wonders can we see in connectivity today? Communicate with street lamps, interact with vegetables, resurrect dinosaurs, and see them up close. Find a way out before despair. In the era when everything is connected, technology brings such imaginations to life. Data communications networks with a super capacity create order out of torrents of data. Data communications networks with intelligent experience replace best effort with SLA guaranteed forwarding. Data communications networks with autonomous driving replace manual intervention on late night shifts with network autonomy and self-healing. Today, data communications networks bursting with intelligence harness the power of the four engines: connect people, connect enterprises, connect computing power, laying a digital foundation for new infrastructure, enabling a digital bridge for all industries. Working behind the scenes, intelligent cloud network ensures shopping is more personalized than ever. Every financial transaction is smoothly made. Valentine's gifts are swiftly delivered via robots. Each question has more and richer answers. Every life receives the respect it deserves. And a new journey can be embarked on fearlessly. Connectivity will never cease to evolve, because no matter where we are, we must connect with our loved ones. And to the road we must take. Connecting value. Connecting hope. Connectivity is limitless. Connectivity knows no bounds.
四山洞拐至下宣线，广州至常州。
There's a house we can build. Every room inside is filled with things from far away. The special things I compile, each one there to make you smile on a rainy day. They can say it all sounds crazy. They can say we've lost our minds. I don't care if they call us crazy. Run away to a world that we design. Every night I lie in bed, the brightest colors fill my head. A million dreams are keeping me awake. I think of what the world could be, a vision of the one I see. A million dreams is all it's gonna take. Oh, a million dreams for the world we're gonna make.
Hello and welcome to the Huawei CloudWAN 3.0 solution empowers connectivity for numerous industries session at Huawei Connect 2021. Digital transformation brings two changes. One is enterprise cloudification, and the other is IP-based transformation of production networks. However, enterprise networks face three challenges: fast cloud but slow network, difficult assurance of deterministic experience, and complex network O&M. In today's session, we will discuss the development trend of WANs and explore how Huawei's CloudWAN solution provides flexible, reliable, and deterministic intelligent connections to empower the digital development of various industries. First of all, let's invite Mr. Snow Yang, Vice President of Huawei's router domain, to share insight into how Huawei CloudWAN 3.0 solution empowers connectivity for numerous industries. Let's welcome.
Hello everyone, welcome to Huawei Connect 2021. I'm Snow Yang from Huawei Data Communication Product Line Router Domain. Today I will introduce Huawei's CloudWAN version 3 solution and how it meets the industry digital transformation requirements. With the continuous development of the new technologies such as AI and cloud, digital development has become a national strategy of countries. With the European Union released 2030 Digital Campus in March this year, covering fields such as 5G chips and AI. The African Union proposed Smart Africa, which aims to development strategy to continuously drive the digital transformation in African countries. China also released Digital China strategy, including digital society, digital economy, digital government, and digital ecosystem. Over 50 countries around the world have released their digital strategies. We believe that digital transformation will bring two changes: enterprise services cloudification and production network evolving to IP-based network. First, we can see from Flex Era 2020 State of the Cloud report that by 2025, 55% of enterprise applications will move to cloud, and 74% of enterprise will move from private cloud to hybrid cloud. Second, production networks are becoming IP-based networks. Services used to be carried by multiple TDM production network will be converged to one network and carried over IP technology, which reduced TCO for customers. IEC and UIC proposed IP-based transformation for power and transportation networks. Traditionally, the cloud and network operate independently. There are three main challenges to achieve cloud and network integration. Cloud services can be deployed in minutes, whereas networks often require months. Secondly, with the migration of service to clouds, best efforts network can not match the service experience requirement. Network SLA performance has a great impact on enterprise productivity. Third, due to the expanding scope of the network connections, the connection density will increase hundreds times and the number of parameters will increase by more than 10,000. Traditional manual maintenance is insufficient. To address these issues, Huawei developed the innovative CloudWAN version 3 solutions to empower intelligent connectivities for industry and digital transformation. CloudWAN version 3 has 4 characteristics: one hop cloud access, one fiber multipurpose transport, one click fast scheduling, and one network worldwide connection. We already deployed hundreds plus commercial cases worldwide. First, let's take a look at one hop cloud access. Traditionally, services provisioning may involve coordination amongst multi-departments. This service provisioning usually takes about 1 month, which is very, very low. One hop cloud access solution uses SDN to define SRv6 cloud path. Services can be provisioned within minutes after configuration at the enterprise and the cloud side. Huawei's latest virtual link technology supports multi-vendor network deployment, including intelligent path computation and optimization. This greatly reduced the customer's network swapping capex and network-wide OPEX. Let's look at a case with Saudi Arabia's NEOM Smart City. This project intends to build high-tech eco-city, integrating government's transportation, finance, and health application system. The traditional MPLS solution requires segment-by-segment service configuration and cross-department collaboration, and the service provisioning time is about 20 days. But with Huawei's SRv6-based one-click cross-domain solution, services can be deployed within minutes, and application-level assurance can be implemented based on different application cloudification requirements. The second capability is one fiber multipurpose transport. Traditionally, the production and the office networks are carried over different physical networks. In particular, the production network needs to be deployed independently to ensure high-quality SLAs for key services. However, such repeated network construction result in a serious investment waste. Currently, Huawei uses the intelligent slicing solutions to implement hierarchical network slicing on one fiber, enabling one network to carry minutes services. Now take a look at a case with Colombia's EPM Smart Grid. The customer's original network carries OT and IT services on multi-network, which is complex in the maintenance and expensive in cost. The network is old and new services cannot be deployed. After IP-based reconstruction with Huawei's RIP and intelligent slicing solution, the customer achieves multiple network convergence and SLA assurance for production services. This helps the customer to reduce the overall capex by 40%, electrical power safety accidents by 30%, and network construction cost by 25%, increasing efficiency and safety while reducing costs. The third capability is one-click fast sharing. It is difficult to an enterprise to select the path with the lowest latency and choose the cloud with the optimal computing power at the same time. According to Huawei's survey, cloud resources utilization in some IDCs is higher than 90%, while others is only 25%. Huawei's intelligent cloud map algorithm considers both cloud factors and network factors during cloud path computation, greatly improving the resources utilization of cloud pros and network resources. Single-pose OTTC, after adopting Huawei's solution, its service development time is shortened from day level to minutes level, and the bandwidth utilization increases from 20 to 50. Jiangsu Smart City, 200 terabits data generated by 90,000 cameras every day needs to be transmitted to the video cloud for storage. The challenge is multiple IDCs cloud pools are unbalanced. As a result, some IDCs need to be expanded frequently. After Huawei's intelligent cloud map algorithm is used, the customer's overall network and the cloud pool utilization is improved by 30%. Each year, the customer can save around 30 million in video cloud storage. The last one is one network-wide connection. In the cloud era, as networks became larger and larger, emerging services pose increasing higher requirements. For example, cloud VR video freezing problem at LGU Plus in South Korea is a silent fault. It takes more than 2 hours for experts to locate such a fault, causing frequent customers complaint. The dozen international airports requires that network faults be quickly located and recovered. This problem cannot be solved by traditional manual maintenance. Huawei is committed to using big data and AI technology to perform an analysis on network data and building digital twins on physical networks. By collecting 80,000 network KPIs and relies in-depth service quality perception and real-time visibility of the network-wide SLAs. In addition, our unique knowledge graphy algorithm can quickly locate the root cause of a fault. For large numbers of potential network risks, we can predict faults several days or even months in advance. We reduce the fault locating from days to minutes and improve the proactive identification rate of the typical network risk from 60% to 90%. Currently, Huawei's CloudWAN version 3 solution and NetEng 8000 series full services intelligent routers have been applied worldwide, such as governments, power grids, transportation, ISPs, and finance industries. They have also been recognized by well-known third-party organizations. To sum up, Huawei's CloudWAN version 3 solution uses the 4 ones capabilities, which is one-hop cloud access, one-fiber multipurpose transport, one-click fast scheduling, and one network-wide connection to build intelligent ones for cloud era, accelerating digital transformation for enterprise. Thank you.
Thank you, Mr. Snow-Yang, for your thought-provoking speech. Next, let's invite Arkadiusz Gedroich, CTO of Huawei CEE and Nordic European Enterprise Marketing and Solution Sales Department, to explore how to enable intelligent cloud network connection and decode the 4 ones of Huawei's CloudWAN 3.0 solution.
Hi, I hope you enjoy Huawei Connect 2021. I am delighted to be the part of it. My name is Arkadiusz Giedroyć, and I am working for Huawei EBG Regional Office for Nordics and Central and Eastern Europe. Many companies which undergo their digital transformation are using more and more cloud services. Using cloud services inevitably means that in one way or another, you are utilizing wide area network connectivity. Today, I would like to present you how Huawei CloudWAN 3.0 solution is leading wide area networks into intelligent cloud network era. I would like to do this in a way to present you 4 features which, in my opinion, differentiate Huawei solution on the marketplace. We call them 4 ones. One hop cloud access, one fiber multipurpose transport, one click fast scheduling, and one network-wide connection. Let's have a look at each and every of them in the next slides. Let's deep dive deeper into the first feature, one hop cloud access. Sometimes to overcome process problems or process inefficiencies, we are implementing or adopting innovative technologies. On traditional network, an MPLS tunnel needs to be configured segment by segment at the access, aggregation, and core layers. However, with one hop cloud access solution, segment routing version 6 needs to be configured only at the 2 ends. This solution also supports segment routing version 6 virtual links, which can traverse multi-vendor IP private lines for dynamic path computation. Which is even more important, this solution is compatible with legacy networks, as long as devices at the both ends support segment routing version 6. So let's have a look how the solution works in a real-world example. Enterprise A uses segment routing version 6 to deploy a site-to-cloud private line to its data center in a headquarters. Traditionally, deploying a cross-domain site-to-cloud private line involves collaboration of many departments in different cities, and services need to be deployed manually. As a result, service provisioning can take 2 or even 3 months. Segment routing version 6 has completely transformed this extremely inefficient process. Segment routing version 6 is an IP version 6 based extension that accelerates private line service provisioning from months to just days. And it can be supported by only upgraded PEs at the both ends. How are you doing in practice? So you select service segment routing version 60 policy template and input the service name. Select source and sync the network element on the topology. Then select color for the policy. You enable statistics collection and real-time bandwidth and set the candidate path. Compute the path, and then you can view candidate path graphically. Then, after selection the candidate path, you can deliver the configuration to the network element. Next, we are going to take a closer look at the second feature, one fiber multipurpose transport. In this solution, hierarchical slicing provides differentiated bearer for numerous services. In the past, large corporations or governments had their own private wide area networks. With Huawei's One Fiber multipurpose transport, all services can be integrated into a single network. Different industries such as healthcare, education, safe city or transportation can use independent slices to carry their own services over the same physical network. Slicing solution from Huawei has 4 key advantages. First, hard isolation can ensure committed SLAs for each and every service. Second, it is able to provide more than 1,000 slices, which is the finest grain in the industry. Third, it does not require planning, which enables fast slice deployment. And this is achievable due to enhancement of Flex Ethernet standard with Huawei fingerprint innovation. And finally, it supports dynamic bandwidth adjustment, which ensures service stability. Let's have a look how does it work in real deployment. Here we have a slice-based private network for electric power industry. Production services for electric power industry have very strict requirements on latency. It is very hard for traditional IP networks to meet these requirements. By contrast, Huawei's network slicing provides hard network isolation to guarantee SLAs of production services. So, throughout network slicing, a physical network is divided into multiple physically isolated networks. Each network carries one of the service, so you can guarantee SLAs for each and every service in each and every slide. So how to do it, how to configure it in practice? So first, here on this example, we have 2 services which are created in slice number 2. One service is for video playing, the other one for simulating congestion traffic. The video is playing smoothly when no congestion in slice 2. After injecting congestion traffic to video, the video freezes with very bad user experience. When we are switching the video traffic to slice 1, the video streams become smooth again. One-click fast scheduling is the third feature of Huawei CloudWAN 3.0 solution. In order to explain you what does it really mean, I need to give you a little bit of the background first. This capability originated from video cloud services of Safe City. In large cities such as Shanghai, there are more than 90,000 cameras generating around 4 terabits of video data every day. And this data need to be carried over the network into the cloud storage. The problem is that internet data centers which provide these services are unevenly loaded. And the main reason is just because the resources of those internet data centers cannot be scheduled properly. Huawei's one-click fast scheduling resolved this by using its proprietary cloud map algorithm to intelligently schedule camera services to the most appropriate cloud pool of resources based both on cloud factors and network factors. So, how does it work in real life? We have many very successful deployments of this technology in financial services sector. For example, one of the Chinese banks' resource usage of its corporate backbone was very uneven. If you look at the slide, some of the corporate network links are used as high as 70%, while the others reach only 20% of usage. This really means that the bandwidth utilization is very ineffective. As a result, bank has spent millions of dollars on private lines every year. To address this issue, Huawei deployed at the customer side software-defined network together with segment routing version 6 and implemented intelligent traffic optimization solution. In this way, we have saved the customer 20% of the private line expenditures which means we have saved them millions of dollars. It is very impressive business case. How you are doing it in practice, you can see at this short demonstration. So traffic utilization is right now over 70% on the red link, as you see on the screen. So in the tool, you can set the bandwidth usage threshold of global links to 70% and start local optimization. After optimization, some services on the red link switch to another link. When traffic data collected after a few minutes, the red link becomes green and the bandwidth utilization is less than 70%. Next, let's have a deeper dive into fourth feature, which we call one network-wide connection. Where is it used? It is mainly used in operations and management field. In wide area network operations and management field, traditional methods rely on sending simulated measurement packets which cannot truly reflect the SLAs of the real services. Huawei innovative iFit solution, which stands for In Situ Flow Information Telemetry, identifies subtle exceptions on the network through packet-by-packet measurements and accurately measures performance indicators such as latency and packet loss rate of each service. With telemetry-based millisecond-level data collection, more than 80,000 network KPIs are collected, and fragmented network data is analyzed with intelligent association, implementing network digitalization and real-time visualization of SLAs. Leveraging the innovative knowledge graph algorithm, locating the root cause of the fault is shortened from 8 hours to a mere minutes. And the proactive identification rate of typical network risks is improved from 60 to 90%. So let's have a look in a real-world example. A fault occurred in one of our customers, which is the ISP, and 1,200 complaints were received within 20 minutes. It took 8 hours to restore the service, resulting in very big problems inside the customer organizations and customer business. When we have analyzed the entire process, we have found out that legacy network had two major issues. First, faults were passively identified, such that 90% of network faults were actually driven by user complaints. Second, once a fault occurs, fault locating in is very time consuming because it is based on manual intervention and on technical expertise of the personnel. And those are the main reasons why it took 8 hours to handle the incident. With Huawei one network-wide connection capability, intelligent learning is supported to detect poor quality of experience in real time. And consumers' pain points are effectively addressed with such a proactive operations and management. So how you are doing in the real life? iFit provides real-time service quality visualization for analysis and assurance purposes. It can help you to quickly learn network status. Through the performance report, you can view different indicators of traffic, find where fault occur. By hop fault location, the faulty link can be found accurately in minutes. In conclusion, Huawei CloudWAN 3.0 can help you accelerate digital transformation throughout its 4 once features, namely one-hop cloud access, one-fiber multipurpose transport, one-click fast scheduling, and one network-wide connection. To better meet wide area network requirements for different customers, Huawei has also launched a full series of NetEngine 8000 intelligent routers. Currently, CloudWAN 3.0 and NetEngine 8000 routers have been deployed in more than 200 e-government networks and more than 50 operators around the world. They have also been widely recognized by institutions and industries and have won numerous awards, such as the Best of the Show Grand Prize Award at Interop Tokyo 2019 and Frost & Sullivan Technology Leadership Award. Thank you very much for your attention.
Thank you, Mr. Arkadiusz Gedroich, for your insightful sharing. On the next topic, let's welcome Jose Carrillo Ortiz, CTO of PTV Telecom, to introduce how to build a future-oriented, simplified fabric network.
Good afternoon, everyone, and thank you very much for taking the time to watch my video. Also, I would like to thank Huawei for the invitation and for thinking of us to share our experience. My name is Jose Carrillo. I am the CTO of PTV Telecom. In this video, I am going to explain how we are preparing with Huawei the evolution of our RAP network to be able to face the challenge of the near future. First of all, let me introduce who is PTV. PTV is an operator with more than 35 years of experience. We were born as a cable TV, and we have been evolving our network to offer new service to our subscribers. Currently, we offer internet with a speed up to 1 GB using GPON, both fixed and mobile telephony and OTT television. The growth of the company has accelerated in the recent year due to the important acceptance that our particular way of understanding the service has had in the market. That makes customers choose us year after year as one of the most valued telecommunication operators in Spain. Our secret is only doing things with common sense and breaking with some widespread practice among telecommunication operators. For example, that a machine attends us instead of a person. Spend 20 minutes on the phone for someone to attend us. Obligation to contract service in the pack that the subscriber doesn't need, etc. Most of the customers have gotten used to this practice, but doesn't mean they like them. Currently, the company is involved in an ambitious project that will lead us to deploy more than 2 million homes in the coming years, opening new locations that will be added to the current one and which we hope to triple the current customer number. This important objective means that we have to resync the current structure of our network and how we are operating it. Nowadays, our network is based on metro routers located in each regional data center and other in 2 large aggregation switches in our central data center. And we access to the internet thanks to two NA40XAA configured in cluster mode. When adding an additional data center or making channels to existing data center, we must configure both the metro router and the main router, which increases the difficulty of the operation and makes it more susceptible to configuration failure that affect the company-wide service. That is why we have decided to evolve the network from 2 aspects. The first is to evolve towards a simplified structured network. For this, we will replace the current aggregation switches with NA8000 M14, connecting the each data center router with them and they in turn with the NA40X8. This configuration will allow us to make the network much more modular, making adding a new data center more agile, simple, fast, and secure, since it will be not necessary to modify the configuration of the current NA40. All the configuration will be carried out in the spine router and in the leaf router. This Lego structure is quite scalable, and we allow to us to introduce all the new data centers without impact for the existing services. Another advantage of this new equipment is undoubtedly its compact design. In the past, up to 14 EUs were needed to have a throughput of 1.6 terabits per second, and now we can practically achieve that performance with just 1 go. This is allowing us to design a smaller data center with lower electrical consumption, which means a significant cost saving. The second aspect in which we are going to evolve the network is to simplify the protocol using it. Although we use a simplified network structure, there can always be a human error that causes a service problem in it. The complexity at the level of protocol in IP networks is important, and in many cases we can find that the configuration of a router can contain more than 6,000 command lines. If we add to this that, as we all know, there is a shortage of STEM profile in the market, it's made it very difficult to find qualified personnel who are capable of dealing with this level of complexity. For our part, we have already experimented with other operation and maintenance systems, such as Access NCA from Huawei, and the results have been excellent. For example, being able to detect massive problems such as feedback broken before receiving the first call from the customer, or detect the affectation from the first minute of the incident. That is why it's made perfect sense to us also take the step with this NCA IP. With this tool, we hope not only to improve the provisioning time of the new site, but also improve the detection of the failure that occur in the network, and therefore also make better the service we offer to the customer. In short, if our network is more simple at the level of structure, protocol, and operation and maintenance, will be faster, more agile, and we will offer better service. That will be more competitive. Thank you very much for your time. I hope you find my presentation interesting. Keep enjoying Huawei Connect. Bye.
Thank you, Mr. Jose Carrillo Ortiz, for your wonderful speech. Next, let's invite Zhang Shicong, CTO of Zhejiang National New Type Internet Exchange, to share exploration and practices of China's IXP development paths.
Distinguished guests, dear friends, I'm Zhang Shicong from National New Type Internet Exchange. I will talk about the exploration and practices of China's IXPs. Internet Exchange Point, or IXP for short, is the Internet infrastructure for effective network interconnection, fair industry competition, and cost-effective solutions. As you can see from the figure on the left, in the traditional model, enterprises use carrier IP addresses and bandwidth to access the Internet. From an architecture point of view, enterprise networks are subnets of carrier networks. Networks paths are configured by carriers. In terms of quality, enterprise in different carrier networks have to go through backbone interconnect nodes, where quality cannot be guaranteed. In terms of cost, enterprises have to pay for bandwidth. In order to improve network quality, some enterprises build private lines to each other. But that means multiple enterprises need multiple private lines, which leads to high transmission costs and complex network egress. That's why MIIT has optimized China's Internet top-level architecture and set up IXPs. As you can see from the chart on the right, in the IXP model, the enterprise itself is an independent network. Enterprise and carriers are interconnected as peers. In this architecture, enterprise networks are at a higher tier and enjoys more flexibility. Enterprises can reach carriers, cloud service providers, and data centers in the IXP ecosystem in one hop, which greatly improves efficiency and quality. From the perspective of cost, enterprises only need to deploy one private line and rent the IXP ports, for which only a moderate fee is charged. Next, let's take a look at the important role IXP has played in the evolution of the global Internet architecture. Before 2000, almost all traffic was directed by carriers. Tier 1 carriers direct traffic to Tier 2, Tier 2 then to local Internet access providers. As a result, Tier 2 and lower tier carriers, Internet content providers, and enterprises were all accessing carrier networks as subscribers and paying considerable network fees. Between 2000 and 2010, faced with explosive traffic growth and high network costs, large Internet companies such as Google began to build their own networks to interconnect with upstream and downstream networks. IXPs were then created to provide one-point access and multi-point connection to such Internet companies. Since 2010, as more Internet companies grew, more IXPs has been built to meet the explosive growth of traffic, becoming an important part of the Internet. As the Markov's law states, the value of network is proportional to the square of the numbers of users it connects. The value of IXPs has been growing ever since. There are now 884 IXPs worldwide, of which 314 are in Europe and 141 in the US. I will briefly introduce three top IXPs. First, DECX, headquartered in Frankfurt, Germany, has exchange nodes in 13 countries connecting 1,021 networks and a peak rate of over 9 terabits per second. Second, EMS IX, headquartered in Amsterdam, Netherlands, connects 1,397 networks with a peak rate of over 8 terabits per second. Both of them were established around 1995. Third, IXBR in Brazil, although established later, has connected 1,548 networks with a peak rate of over 11 terabits per second. It's the largest one worldwide. Its fast growth can be attributed to the 33 exchange nodes in the country, bringing together universities, DCs, government agencies, banks, energy, communication, and internet companies into this very large ecosystem. That was the global IXP market. Now let's pivot back to China. Since 2013, China has built 16 backbone nodes for interconnection between carriers, which greatly improved quality. It should be noted that these backbone nodes are not open to enterprises. The new type Internet exchange points were set up to solve the problems of interconnection between enterprises and carriers. 3 were approved, and Zhejiang Internet Exchange Points was the first. With backbone interconnect nodes and new type Internet exchange points, China's interconnection architecture is substantially improved. Initially, IXPs in China had an insignificant role. They were established for many reasons. One of them is to narrow the gap. As you can see from the chart on the left, in the 20 years from 1998 to 2019, interconnection paths became more complex. China became an increasingly important node on the global internet, but there is still a gap compared with the leading countries. The second reason is to enable new infrastructure. Emerging technologies like 5G, cloud computing, AI has given rise new requirements on interconnection such as lower latency, more accesses, and lower cost. The exchange point can provide an integrated ICT infrastructure with network, computing, and storage. Next, I will introduce the practice of Zhejiang Exchange Point. As the first of its kind in China, it was officially approved by MIT in October 2019 and established in June 2020. 9 stakeholders include the 3 major carriers in China, Alibaba, Wazoo, and NetEase. It is a semi-non-profit organization in accordance with the principles of neutrality, fairness, openness, and meager profit set by MIT. It has built a network scale and is steadily expanding according to the guidance of competent authorities. At present, there are 4 access points. In Hangzhou, enterprises can choose single-point access nearby or multi-point access for better availability. New nodes are planned to be built in areas with IDC clusters, KCDs, and industrial areas in Zhejiang to bring more companies into the ecosystem and reduce access costs. Ecosystem is taking shape and thriving with support of industries. As of the first half of this year, 55 enterprises are connected to the exchange point with a bandwidth of 2.9 terabits per second and peak rate of 446.6 gigabit per second. The connected enterprises included the leading enterprises such as 3 major carriers, Alibaba, Tencent, Huawei, JD, NetEase, Wazoo, Geely, Dahua, Jinshan Cloud. Among the access ports, 1/4 of the access ports are 100 GE, 1/4 10 GE, and another half 1 GE. With the support of Huawei and other industry partners, we explore new technologies to stay ahead. Facing explosive growth in cloud computing and strong demand from Internet of Everything, we fully leveraged advantages of cross-domain and cross-industry convergence to create a new interconnection mode ICM, I for Internet Exchange, C for Cloud Exchange, and M for Manufacturing Exchange. We've also adopted SDN, RS, and SRv6 to build an integrated intelligent XP infrastructure and develop a dual-plane computing power scheduling network for cloud network convergence. Our vision is to promote the continuous upgrading and evolution of China's internet, create an equal, open, and secure network ecosystem, and contribute to the making of a connected and digital China and prosperity for all. We will implement the priorities set by MIT and the Cyberspace Administration, such as to explore the development paths of new type XPs in China and to promote the upgrading and evolution of next-generation internet. In the province, we are committed to building a provincial network infrastructure that can serve the entire country, promoting interconnection and balanced development in the province and prosperity for all. Under the leadership of the Interconnection Working Committee of the Internet Society of China, we will work closely with our industry partners. I also call on industry partners to join us on the journey to build fair and ubiquitous connectivity. Thank you.
Thank you, Mr. Zhang, for your wonderful speech. Well, that brings us to the end of today's session. See you next time.